Okay, I'm back. So be able to factor, right? Remember, you try to factor by looking at the constant term. If you have a quadratic function, look at the constant term. Make sure your factors will add up to the coefficient of the middle term. Right? If you're able to do that, then you're in good shape. Right? Let's look at an example. Let's say if I have negative x squared minus x plus 20. How do I factor this? Well, the way it looks a little confusing. So the best way to do this is to factor out the negative. If I factor out the negative, look what I have. I have x squared plus x minus 20. Right, now I can find two factors of negative 20 that will add up to a positive 1, the coefficient of x. Now, this will give me negative, don't forget your negative, so that will give me what? 5 and negative 4. So x squared, x minus 5, x plus, I'm sorry, I have this backward. Okay, so x plus 5, x minus 4. Okay, so we can double check here. X squared negative 4x plus 5x give me the x. 5 times negative 4 gives me negative 20. Here are your factors. Okay, don't let the if you can factor out a negative and you find out that that helps you, do factor out the negative. Right, this one is not a prime because it can be factored. Okay. Now, the other things you can do, remember, if you cannot factor it the way it is, you can always use the quadratic function, the quadratic formula. Remember, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. Remember your quadratic formula, right? Very important to remember that because it always comes in handy when you cannot factor. Remember, what is a? A is the coefficient of x. X squared, I'm sorry. B is the coefficient of x, and c is the constant. Okay, so if I have an example, x squared plus 7x plus 21, so what is a here? A is 1, the coefficient of x, b is 7, and c is 21. Okay, then you say, okay, what is minus b? Minus b is minus 7. Stick your minus 7 here. Plus or minus the square root of b squared, that's 49. Minus 4, a is 1, and c is 21. Divide by 2 times 1. Okay? So let's look at the next one here. Okay, be able to identify the difference of two squares. Remember, how do you factor the difference of two squares? The difference of two cubes and the sum of two cubes. Be able to do those. Difference of two squares, difference of two cubes as a cube minus b cube, and the sum of two cubes, a cube plus b cube. I guarantee you, you need to know those. Those will be on the test. Okay? Now, if you're given fraction, how do you simplify rational expression? So let's say I'm looking at x plus 3 or x plus 2 is equal over x minus 7 minus x minus 9 over x plus 8. Right? If I want to simplify this rational expression, so how do I do that? Well, first of all, I need to find the least common denominator. In this case, the least common denominator is x minus 7 and x plus 8. Okay? So, now what do I need to do? I need to have the least common denominator at the bottom, so I'm going to multiply the top and the bottom by x plus 8. So, x plus 2 times x plus 8. Okay? Going to do the same thing for the second one. So, I have x minus 9 over x plus 8. So I want to have the least common denominator here, so I'm missing the x minus 7. So I'm going to multiply the top and the bottom by x minus 7. Remember, these, if you don't need them, they cancel out and give you your original expression in both terms. Now, the denominators are the same. So you can just simplify the top, combine the fraction now. So you have x plus 2 times x plus 8 minus x minus 9 times x minus 7 over the least common denominator, which is x plus 8 and x minus 7. Now what can you do? You go ahead and multiply this out. Right? I'm not going to continue this. Minus, multiply this out, simplify the numerator, and then put your numerator here and the x plus 8, x minus 7 at the bottom, okay, and you're done. Okay, that shouldn't be too hard. Remember, if you multiply this out, you'll get x squared plus 8x plus 2x gives us x squared plus 10x plus 16 minus, remember, put your big parentheses here, x squared minus 7x minus 9x gives us minus 16x plus 63. Now you change, remove the parentheses, change the sign, and then simplify. Okay, I'll let you finish this. Very important. I don't want you to give you too many hints on those, right? But definitely you're going to have to to know how to do this to do well on the test. Now, let's look at a complex rational expression. So if I have xz plus q to the power of negative 1 over z to the power of negative 1 plus q to the power of negative 1. So don't let those negatives scare you, because the top is just 1 over, right? Make that exponent positive is the first thing you want to do, right? That's for the top. For the bottom, 1 over z plus 1 over q. Now this looks familiar now, right? So what we can do is combine the bottom, have one fraction if you want to. So we have 1 over z plus q, right? Remember, the least common denominator at the bottom here is z times q, right? Z times q, right? LCD here is z times q, right? So you have here, you need to multiply to get q. At the bottom, you need to multiply the top by q as well. So you have q over zq, right? These two cancel, you get this one back. Plus 1 over, again we do the same thing. We're going to multiply the top and the bottom here by z. So you're going to have z over zq. Okay, combining, we have 1 over z plus q divided by q plus z over zq. Now, fraction divided by another fraction, convert it to multiplication. What do you have? So this becomes 1 over z plus q. Flip the bottom, ZQ over Z plus Q. Much simpler now, right? So you have ZQ over Z plus Q to the square. Okay, looks complicated, but it is not. Okay. Okay, couple of word problem that you need to be able to do. Now let's look at an expression that you need to solve with a radical, right? When you have a radical, you have to make sure that you simplify. For example, you need to know when to add the exponent, when to multiply the exponents, when to subtract the exponents. Right? Remember, if you have the same base, you're multiplying two expressions with the same base, you just add the exponent. Right? If you're dividing, you subtract the exponent. Right? If you're raising to the power, you multiply the exponents. Okay? Okay, I'm looking at some of the hard ones for you here. So how do you rationalize the denominator, for example? So if you have 2 over the cube root of 12y, how do you rationalize this? Right? Remember, you don't want to multiply by the cube root of 12y. It's not going to work, right? If you multiply the cube root by the cube root, you do not get rid of the radical sign at the bottom, right? So somehow you need to be able to take the cube root of what can you have y. How do you take the cube root of y? What do you multiply y by to be able to take the cube root of y and get rid of the radical? Okay, so let me rephrase this. I think I may have confused you here, but here we go. So we have cube root of 12 and cube root of y. So here, what I can do, I can multiply the bottom here by y squared, right? So you can multiply this one by y squared. Then the cube root of y squared, so the cube root of y squared times the cube root of y is equal to the cube root of y cubed, which is just y. So to get rid of this radical here, you multiply by the cube root of y to the squared, right, for the y. And of course you have to do the same thing to the top, the cube root of y squared. Now how about the 12? The 12, how do I take the cube root of 12? Now there's a couple ways to do this, right? For example, the cube root of, you can multiply by, okay, let's do it the hard way. I mean, I'm trying to make this as simple as I can for you. So let's multiply by the cube root of y12 squared, right? Although that's not the simplest way, but that would work, right? Whatever you do at the bottom, you have to do the same thing to the top. So here you have, right, the cube root of 12 times the cube root of 12 squared is the cube root of 12 cubed, right? Here you have the cube root of y to the cube. The top, you have 2 times the cube root of 144, right, times the cube root of y squared. You can combine these two here. We'll do that in a second. But look at the bottom now. The bottom is, this is 12. Cube root of 12 to the cube is 12. The cube root of y to the cube is y. Okay, the top you can combine these two because we have the cube root of 144 y squared. Okay, a little more complex than the previous ones, but you should be able to do this one. Okay, so I think we are close to finishing here. Remember a couple of things here you need to remember. If you have the square root of a negative number, for example, the square root of negative 16 is 4i. Okay, remember that? So if I want you to take a square root of let me explain why. So this is the square root of 16 times the square root of negative 1. That's the square root of negative 1 by definition is I. Square root of 16 is 4, so you have 4i. Okay? So if I tell you what's the square root of negative 64, that's, right, 8i. Okay? So you should be able to simplify those, add them. Remember, I squared is negative 1. So remember, if I is equal to square root of negative 1, if you square both sides, right, what do you get? That's I squared is equal to square the square root. So you just get negative 1. So in your expression, when you solve them, always remember, if you have an I squared, replace it negative 1. Okay? Okay, that's it. That's all I have. Review. You should be able to do those. Now, always remember, you can also solve, let me do one of these for you here. Solving system of linear equations. Well, let me stop the recording and then start another one because this may